So in this video, I was going to show how to create a double helix, like a DNA double helix. And I'm going to be using subdivision surfaces, although you could really do this as a complete poly model also. But the technique would pretty much be the same thing. So the first thing I'm going to do is create a disk, and I'm going to create it in the top view. And I'm gonna move the disk away from the center point, the 0 point, and this is going to determine how wide the actual helix is. As you can see, I'm using a pretty low-sided cylinder. I'm only going to use 6 sides, and that's going to be enough to keep the shape that I want. I'm going to kind of want like a flattened out cylinder when this gets extruded during the process. And I'm also going to zero out on the z-axis, and that looks good to me, so I'm just gonna accept that. I'm actually gonna flip the poly, so I'm gonna hit the F key to flip it, because we're gonna be essentially extruding or lathing this up in a second. And I'm gonna go into the right view now, and I'm actually going to rotate this slightly, maybe about it doesn't have to be exact, but probably about 45 degrees, because this is going to be going up in this direction as it gets extruded, or as it gets lathed out. So now I'm going to use the lathe tool, and we're going to go in the. Actually, I'm gonna zero this out and kind of clear out some of these settings to make it similar to what you might see as you do this. I'm gonna do it in the y-axis, and so this is something you might see as you initially start. Those settings were there from the last time. So the first thing I'm going to do is I'm going to want this DNA helix to, I'm going to go with about 5 revolutions, so 5 kind of wraps. If you wanted a really long strand, you could obviously do more revolutions. So I'm going to type in 360, and I want it to wrap around 5 times, so 360 times 5 right in the numeric palette, and I'm going to accept that. That gives us a total of 1800 degrees. And because I'm going to be using subdivision surfaces, I'm going to go with maybe something that's about, I think maybe 8 sides would be fine. So 8, and we're going to have 5 revolutions again, so 8 times 5, that's going to give us a total of 40 sides. And as you can see, that doesn't really look like anything we want. So I'm going to put an offset in there. And I'm going to maybe put an offset of, let's say, about 60 meters. And if I do a fit all, if I hit the A key to fit all, you can see that looks like the beginning of a helix, or at least one side of it. So that looks pretty good. I'm going to accept that. I'm going to hit the return key. The thing you do want to take note of is you don't want to forget that we used 5 revolutions, and you don't want to forget that we was 60 meters tall, because we're going to be using those values as we continue this. So I'm going to accept that. I'm going to do fit everything, A key to fit everything into the screen. And now make sure you're in polygon mode. I'm going to select all the polygons. I'm going to copy and paste that. And then when I hold down the control key, I'm just going to rotate this 180 degrees. So essentially we're rotating a copy of this 180 degrees. And then accept that. I'm going to deselect everything. And that pretty much is your double helix right there without doing any more work. And if we hit the tab key to go into subdivision mode, I'm using Catmull-Clark. You could see that it subdivides really nicely. If you wanted to, you can cap off these ends, and I will just do that really quickly, in case you wanted to use the standard subpatch. And one quick way would just be to select the endpoints, hit the L key to connect, and essentially end up with 1 quad and 2 tries. But that would be okay for the standard subpatch in Lightwave. And I will just do that on essentially on the 4 ends that we have. It probably would have been a little bit quicker if I had done this on the first one before copying and pasting it, but that really won't add too much time. So again, I'm using the L key to connect that, and then just deselecting everything. Okay, so now we have the outer part of the double helix, and we're going to now create essentially the little bars that wrap around all on the inside, like you typically see on the representations of a DNA strand. So I'm going to go into layer 2 and put that first layer into layer 1. I'm going to go again into the right view, and I'm going to zoom in right towards the bottom, pretty much at the 0 point, and I'm going to use the disc tool to create another cylinder. I'm going to stick with 6 sides. We probably don't need too much detail on this, and 6 sides is going to be enough once we subpatch this object. You don't want to make it too big because you don't want this, essentially the cylinder that we're going to be creating, you don't want it to stick out from the sides of the rotating objects or the helix objects. And then I'm just going to pull out the sides so they're about centered in the width of the object that it's between. And I'm going to accept that. I'm going to go right into the back view, and with the knife tool I'm just going to add a loop very close to the edge on both sides. I'm just going to right click here to create another cut. I'm going to accept that, and now if we go into subdivision mode, at least those edges aren't going to be too distorted at the ends. So if you did want to get that ready for the standard subpatching, if you just select that polygon under the multiply menu, you can go to make pole under the subdivide section, and that will just essentially cap off that end so they're all tries at the end, and that will hold the shape of it a little bit better. That's not going to be too much of a concern, as you really won't be seeing that part of the object, but we could just do it really quick in case some of you did want to use the standard subpatching. I know a lot of people have a preference for that. So the next thing I'm going to do is, I didn't want this to be a standard bar that goes right across, or a standard flat continuous cylinder. I'm going to make it a little more interesting of a shape. So I'm going to use the stretch tool and kind of make this more of a flattened cylinder. And maybe stretch it a little bit wider. But I also didn't want to have it go around the helix like this. I want each side to kind of follow the flow of the helix. So what I'm going to do is I'm going to select the points on this first side, and then with the rotate key, or the rotate tool, I'm going to rotate that side so it follows the flow of that edge, and just accept that. And then I'm going to select the points on the other side, and with the rotate tool I'm going to get it so it follows the flow, the general direction of the other side of the helix. And if you go into subdivision mode, you'll see now that the flattened cylinder's there, but it kind of warps in the same direction as each side, and I think it'll just look a little bit neater. It's not really necessary, just kind of something that I thought would look kind of cool. So I'm just actually going to exit subpatch mode now. I'm going to do a fit all, and now the next step is to essentially create the rest of those connector bars. And this is the point where you are going to have to recall some of the settings that we used to create the actual double helix. So the first thing is number of clones, and you need to, at this point, we have, I'm going to use 10 for each revolution, so we have 10 clones, and we had 10 total revolutions, 10 times 5. So that's a total of 50 clones that we're going to want. As far as we're going to want to offset in the y direction going vertical. So we had, let's see how we did this. We have 60 meters, so we have 60 meters right there, and you want to divide that by the number of revolutions. So we had 60 divided by 5, so that's 12, and then we have 12 divided by number of clones per revolution, so 12 divided by 10. So each one is going to move 1.2 meters. And then as far as the total rotation, we have 360 degrees, and we're going to divide that by the number of clones per rotation, which was 10. These are just numbers that we happen to pick arbitrarily. But using these numbers, the clones should match up exactly to the spacing of the double helix. So if we did this correctly, we click OK, and we zoom in, you can see each of those clones fit in exactly with the double helix. So I'm going to enter subpatch mode again, hit the tab key, and I'm going to go into layer 1 and turn on subpatching or subdivision mode on that first layer. I'm going to enter full screen mode, and you can see we have a really nice double helix, very interesting shape, where each of the connector bars are following the flow of that side of the helix, and they lined up perfectly with the shape of the helix. So just with a little help of some math, we were able to create a very cool looking double helix. If you were going to use it like this, you could probably just go in and select that very first one and delete it, because it's not really connecting all the way, and also the very last one, select that one and delete it. And then that model right there is pretty much a done, finished model. So I hope you found this useful, and have fun creating some DNA double helix strands.